Hi everybody! In this video we're going to be going through the notes for lesson 4.4, which is all about modeling with linear equations. So the idea of today is I'm going to give you a story and I'm going to ask you to write an equation and solve it to figure out the answer. When I do that, the first step, no matter what, is always going to be to define the variable. This means that I want you to explain using words what the letter in the problem represents. And the easiest way to do that is to look at the question. In a math problem, the question is usually the last sentence, and it will tell you what the actual question is that you're trying to answer. Whatever it says you're trying to find, you're just going to copy and paste those words as your variable. Before we talk about how to actually write the equation, let's look at one example of that. In problem number 1 here, it says the milk supplier charges 35 cents per carton of milk in addition to a delivery charge of $75. If Elvira spent $232.50, how many cartons of milk did she buy? You'll notice that step 1 here is to define the variable. So all I'm going to do is read the last part of the last sentence. How many cartons of milk did she buy? I'm going to copy and paste those words. So I'm going to say X equals the number of cartons of milk she bought. It's as easy as that. Just read the last sentence and copy what the question says. Now let's get to the how do we write the equation. These types of problems are going to come in 2 styles. For style number 1, you're going to know a pattern. There's going to be something that happens over and over and over again. In these styles of questions, there are going to be 3 important numbers that you're going to need to find. There's going to be a one-time number, which is a fee or a charge or a cost or a number that only happens once. It could also be the starting number that you had because you're only going to have that number at the beginning. It's only going to happen once. The second number you're going to find in these problems is the pattern number. The pattern number is going to be something that repeats over and over and over again. You're going to look for the keywords per or each or every in order to identify the pattern number. The last number is always going to be the total. This is going to be like the ending amount or the total amount. Once you find those 3 numbers, here's how you put them together to make an equation. You're going to put the one-time number first. And then you're either going to have a plus sign or a minus sign, depending on whether your pattern tells you you're getting bigger or smaller. And then you're going to have your pattern number. Then you're going to multiply by your variable. I like to use the letter X. And then equals the total. So let's go back to that problem we already read. It says the milk supplier charges 35 cents per carton of milk, in addition to a delivery charge of $75. If Elvira spent $232.50, how many cartons of milk did she buy? Now there are 3 numbers here. The first number is going to be a pattern number. You'll see the word per here. That tells me that this number right here is a pattern number. So I'm going to circle it and I'm going to write the word pattern number by that. The second number is a delivery charge. Now a delivery charge is something you only have to pay once. So this would be a one-time number. You don't have to pay a delivery charge on every single item. You pay it once for the whole shipment. The last number over here is the total amount that she spent. So I'm just going to circle it and label it total. Now that I identified those three numbers, I'm going to put them together to make an equation. 75 plus I'm also going to pay, it says in addition to 0.35 cents, X, because X goes next to the pattern number, and then equals my total, 232.50. Once I have that equation written, I'm just going to solve it, just like I've been practicing. So for this particular problem, I'm going to start by subtracting 75 on both sides. When I do that, I get 0.35x equals, I'm just going to use my calculator for this, 157.50, and then I'm going to divide by 0.35. Which means that I get x equals 450. Now the last thing that I'm going to ask you to do is to interpret this answer, which basically means tell me 450 what? To do this, I'm going to go back to my variable. This variable was telling me the number of cartons of milk she bought. So I'm just going to say she bought, and now I know the answer, 450 cartons of milk. Let's try another one. It says here the school cafeteria started with 130 gallons of ranch dressing. Each day the students use about 2.25 gallons of ranch. The cafeteria reorders when there's 20 gallons of ranch left. So how many days will it take before will the ranch dressing supply last before needing to reorder? Let's start with defining our variable. Again, I'm just going to read the question. How many days will the ranch dressing supply last before we need to reorder? So I'm going to say x equals the number of days the ranch supply will last. Then I'm going to go back and find my numbers. So there's going to be a one-time number, a pattern number, and a total. It says here we started with 130 gallons. That's going to be a one-time number. You only have that amount at the start. Then it says they use 2.25 gallons of ranch each day. So if they use it every day, that's a pattern. But it's also going to be a subtracting pattern because we're using it up. At the end, I'm going to reorder when there's 20 gallons left. So that's the total at the end. That's how much is left. Then I'm just going to make an equation. So 130 is my first number minus 2.25, and then that's where I put my x because that's my pattern, equals 20. Now I'm going to solve. So I'm going to start by subtracting 130 on both sides. That gives me negative 2.25x equals negative 110. Then I'm going to divide by negative 2.25. So we get x equals, and on my calculator, I'm going to do this, 110 divided by 2.25 negatives, I get 48.8 repeating. So I'm just going to write that little repeating sign there. Now, let's interpret. Remember, this was telling me the number of days the ranch will last. So I'm just going to say the ranch will last 48.8 repeating days. and I'm done. In other words, I should probably reorder on day 48 because I'm not going to make it to day 49. Last but not least, let's talk about the second style. Sometimes, instead of knowing a pattern, we actually want to figure out the starting number. If we are going to talk about a pattern, we have to have something to start with, but in this case, we don't have a starting number, so there is no pattern. The key words you're going to look for is in the question, it's going to say how much or how many at the beginning or at the start. If you see how much or how many were there at the start or at the beginning, it's a clue that you're using a different style of equation. This problem is not going to have a beginning number like a one-time number and a pattern and a total. Instead, it's going to have a list of operations that you're going to turn into an equation. So let me show you an example. Joanne doubled the number of flowers in a vase. Then she removed 3 flowers. The final flower arrangement had 47. How many flowers were there in the vase at the start? Now, if I define my variable, it says how many flowers were in the vase at the start. So I'm going to write x equals the number of flowers in the vase at the start. Now again, I'm seeing the words at the start, which means there isn't going to be a pattern. And sure enough, if you read these words, it doesn't say that she removed 3 flowers every time. It doesn't say that she doubled the flowers every time. It just says she does everything once. So when that's the style of problem, the first thing you're going to write down is x. Then you're just going to do the operations. The first operation it says here is that she doubled the number of flowers. Doubling is another word for multiplying by 2. So I'm going to take my x and I'm going to put a 2 at the beginning to show that I multiplied. That says that then she removed 3 flowers. Removing is another name for subtracting. So I'm going to put a -3. And then it says the final flower arrangement had 47. So at the end, this was equal to 47. Then I'm just going to solve it like normal. So I'm going to add my 3 on both sides. And I get 2x equals 50. Then I'm going to divide by 2 on both sides. And I get x equals 25. To interpret the answer, I'm just going to say that this was the number of flowers in the vase at the start. So at the start, there were 25 flowers in the vase. And that's it. Thank you so much for watching, and I'll see you soon for some practice.